In this video, we're going to learn how to start working with ECS in Unity 2019. We're going to cover what is ECS, how it's different from game objects, and then we'll write a nice test to see the code in action and how ECS enables epic performance. Let's begin! Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Okay, so first of all, ECS is one of the pillars of the new Unity Dots tech stack. If you want to learn more about Dots, check the link in the description for the video where I go over what it is, how it works, and what are the benefits. Essentially, Dots is composed of the C# job system, the burst compiler, and the entity component system. The main difference when writing ECS code is switching from an object-oriented design into a data-oriented design. In the classical way of working with monobehaviors, you have data and behavior in the same object. Whereas in ECS, those two are separated. You have components that simply hold data, systems that do work on that data, and finally an entity which contains instances of component data. So with the theory out of the way, let's get to writing some code. First, to get started trying out ECS, you need to be using Unity 2019. Then go here into Window and open up the Package Manager. As of this recording, the Entities package is still in preview, so you need to go into Advanced and enable Show Preview Packages. Then here, scroll down and install the Entities package. Related to that is the Mathematics package. This is a math library specific with performance in mind. And finally, the Hybrid Renderer package. This is what we're going to use in order to render our entities. Other packages related to Unity Dots are down here, the Jobs package, and up here, the Burst compiler. But for now, we're just going to focus on simple ECS, so all you need is the entities, mathematics, and hybrid render. So with all of that, we have all the components to start playing around with the entity component system. Alright, so let's start off really small. First, let's make a normal script just to run our code. So in here, make a new C# script. Let's call this just testing. And let's add it to a game object. So a new game object. Call it testing and drag our script. Okay, so here we can test our code. Now the simplest thing we can do is just create a new entity. So for that, first we need to go up here and make sure we are using unity.entities. And then we can test our code on private void start. And here to create an entity, we need to use the entity manager. So we grab it from the world.active.entity manager. This is the class that manages all of the entities. Then we can simply go into the entity manager and we just call create entity. And just like that, we have created a simple entity. So let's run the code and see. Okay, our code is running. Now all we did was create an empty entity. There's no renderer or anything attached to it, so obviously there's nothing to see here. However, we can go into Window, into Analysis, and the Entity Debugger. So here is the Entity Debugger, and here indeed you can see we have an entity. Alright, so that's our first step, creating a simple entity. Now let's go into the second part of ECS, which is adding components. So let's make a simple component. Let's say that we want this entity to have a level like in an RPG. So we want to make a new component in order to hold that level. So in here, we make a new C# script. Let's call this the level component. And in here, let's get rid of the normal monobehavior code. And instead, we're going to be using unity.entities. And here we extend iComponentData. This is what we need in order to be able to use this as a component. Another difference is components are always structs, so this is not a class, but rather a struct. And now in here, we just add all the fields that we want. So in this case, for our level, let's just add a public float for the current level. All right, so that's pretty much it for our component. Again, remember, components only hold data. They don't have any behavior. So now we can go back into our testing class. And in here, when we create an entity, you can see that we can pass in an array of component types. So in this case, we pass in the component of type level component. So just like that, our entity will be created with a level component. So let's see. So here we are, the code is running, and on the entity debugger, we can click on the entity, and here in the inspector, you can see that it does indeed contain a level component. Okay, so far so good. Now back in the code, let's say we want this unit to start off at level 10. So for that, we use the entity manager in order to set the component data. Then we need a reference to our entity, so let's grab it here. And we set the component data on that entity. And for the component data, let's pass in a new level component. And we're going to start them off at level equals 10. So we are telling the entity manager to set the component data of this type with these values. So let's test, and we should be able to see our entity with level 10. And yep, here's the entity debugger, and our entity 0 is indeed on level 10. Okay, so far so good. So we can create an entity and add a component onto it. Now let's look into the last part of ECS, which are the systems. In order to make a system, all we need to do is create a class that extends the component system. So let's make a new C# script. This will be our level up system. And in here, again, get rid of the mono behavior code. And for a system, we extend component system. As you can see, there's an error because we need to implement the onUpdate method. So this function will be called on every update. And now in here, we want to increase the level for every entity that has the level component. So to do that, we do entities, and we do a for each. And here we pass in an action with the components that we're looking for. So in this case, we want our level component. The ref parameter means this is a reference, so we will be able to modify the level component data. So in here, the code will run on every entity with this particular component. So in this case, let's just increase the level like we would any other variable. So we go into the level component and increase the level by, let's say, 1 level per second. So 1 multiplied by time.delta time. Okay, so we should be able to increase the level by 1 per second. Also, the code in here is running on the main thread, so that means that we can use debug.log. So for example, do a debug.log of the level component.level. And that's pretty much it for making a system. We don't have to go back into our main class to add anything. All we need to do is make it a component system, and with that, it will automatically run. So let's run the code and see. Okay, the code is running, and on the entity debugger, we have our entity 0. And indeed, as you can see, the level component level is indeed increasing. And here on the console, we can see that it is indeed increasing. Okay, awesome. So we can create entities, add components, set their starting data, and we can also make systems that modify that component data. So hopefully this example has been simple enough to follow along so far. Now let's look into a couple more essential basic things, and then we'll work on actually adding a visual to our entity. So first, here in our testing class, we are creating an entity and passing in a level component. Now let's say we want to add a second component. We could do that by adding simply another type of and passing the type of the second component. However, the better way to create an entity with specific types of components is to create what is called an entity archetype. So an archetype is essentially a specific set of components. So up here we can define an archetype that contains all the components that we want. So we ask the entity manager to create an archetype, then we pass in our component types. So in this case, first the type of level component. And for a second, let's add the standard position component. So that's the type of translation component. The translation is inside unity.transforms. You can inspect this pre-made component. In order to see that it's very simple, it simply contains a value, which is a float 3. And a float 3 is essentially a vector 3. As you can see, it's inside unity.mathematics and simply has an x, a y, and a z. And that's it. We just created an archetype containing the components, level component, and translation. Now we want to create an entity using this archetype. And all we do is in here on create entity, we pass in our archetype. So we should be able to see a new entity being created with the level component and the translation component. Let's see. And here's our entity, and it does indeed have the level component and the translation component. So as you can see, if you want to make, let's say, a bullet or an enemy, you would make an archetype for each different type and then instantiate that. Now, one of the main benefits of ECS is getting massive performance. So making just a single entity isn't very fun. So instead, let's make a bunch of them using the same archetype. The create entity function has a variation that takes the archetype and then takes a native array of entities. So we create an array and then that array gets filled with entities. So let's create here a native array. Now in order to use the native array, we need to be using unity.collections. So create a native array to hold entities. Entity array. And here we instantiate the array. Let's pass in our size. So for our size, let's start off very simple. So just with 2 entities. And then we pass in the allocator. This will depend on exactly what you want to use the entity array for. So in this case, we just want to use it to instantiate our entities, and then we don't need the array, so we use temp. Okay, then we pass in the entity array into our create entity function. And now this one no longer returns an entity. So all of the created entities are now passed into this array. So now we just need to cycle it. So we cycle. And here we grab the entity, which is on the entity array on index I, and we instantiate it with a certain level. So in here, let's start off with a random level. So we are now correctly initializing all of our entities, and afterwards we need to make sure to dispose of our native array. So entity array, and we simply call dispose. All right, so we should now be creating 2 entities using this archetype. And each of them will have a random level, so we can see that they are different. All right, let's see. Here's the entity debugger, and indeed you can see we have 2 entities, and here you can see that they have different levels. This one is on level 30 and this one on 26. Okay, awesome. So as you can see, this is how you create multiple entities. Now instead of just 2, let's try spawning a lot more. So instead of 2, spawn 2000. Let's see. And in the entity debugger, you can see that we are indeed creating 2000 entities, and all of them are increasing their level. And if we check out our stats, you can see that our CPU isn't working very hard with regards to updating 2000 entities. Now, obviously, it would be nice to be able to actually see them, so let's see how we can add rendering. Here in our testing class, first of all, let's go back to just 1 entity so we can easily make it. And on the archetype, we have the level component, the translation component, and now in here, let's also add a type of render mesh component. The render mesh is inside using unity.rendering. This is what we're going to use in order to render a mesh. And in order to view it, we also need to add the type of local to world component. This is what the renderer uses in order to calculate how it should be visible. Okay, so now that we have our archetype set up, in here we need to set the component data for the render mesh. Now the render mesh is not a component, but rather a shared component. So we need to go into the entity manager and call set shared component data for the entity, and then we pass in the render mesh. Here is the definition for the render mesh. As you can see, we have a mesh, a material, and then a bunch of things. So let's add a field to be able to use a mesh in material. So in here, make a serialized field. Let's pass in a private mesh for our mesh. Another serialized field for a material. Let's drag them in the editor. So for the mesh, let's simply use the default quad. And for the material, let's create a material in here. So a new material, let's call this our sprite material. For the shader, let's use the unlit transparent. And let's pass in this zombie flying body texture. Okay, and drag it onto our field there like that. Okay. Now back in the code. For the render mesh, let's pass in the mesh as our mesh and the material as our material. Okay, so that's pretty much it. Our entity should now be visible using the quad mesh and our zombie texture. Let's see. And yep, there's our zombie being displayed on 0, 0. And if we go into the entity debugger, you can see that it does indeed have the render bounds, world render bounds, local to world, the render mesh with our mesh and material, and the translation, which is his current position. Okay, so here it is, just sitting around. Now let's make him move. So here we are already instantiating with the translation component, which contains the position, as we saw. So let's make a system that moves him. So down here, make a new C# script. This will be our mover system. And in here, we're going to do very much the same thing we did with a level system. So we need to implement component system. And on our update, let's do entities, cycle through for each entity. And let's grab the entities with the translation component. So in here we have the code that will be run on every entity that contains a translation component. And here let's just modify the translation.value, and we just modify the y. All right, that should do it. So let's see if our zombie is indeed moving up. And yep, there's our zombie and he is moving up. Okay, great. Now let's make a move speed component. So in new C# script, this will be our move speed component. Then here again, let's do the same thing we did on the level component. So we simply create, first of all, this is a struct. It implements iComponentData. And for the move speed, all we want is a public float for our move speed. Now on our testing class, let's add this to our archetype. So we add the type of move speed component, okay? When we create entities, let's set the move speed component data. And let's spawn 5 entities. And let's also spawn them on different positions. So let's set the component data for the translation component. And here for their starting value, let's put them on a random position. Okay, so here we are initializing our entity. First we add it with the level component and we set it on a random level. Then we add the move speed component and we pick a random move speed. And then we also set the starting point of the translation component, which is going to be his position. So we just randomize on the X and the Y. Okay, so we should now have 5 entities. Now let's see how they're going to move. So here on the mover system. And here we want to run our code on entities that contain both the translation component and also the move speed component. So every entity that contains both of these we're going to run. Now when we run this code, we move it by the move speed. And then let's just make him bounce when he hits the top of the screen. Okay, so we move him according to the move speed on this entity's move speed component. When he gets to the top, he starts moving down. When he gets to the bottom, he starts moving up. Okay, very simple. So we should be able to see our zombies going up and down. Let's see. And yep, there we have our 5 zombies. They go up, they go down, and everything is handled by components and systems. And as you can see, they are going at different speeds based on the move speed component that they contain. So we can go into the entity debugger. Here we see all our 5 entities. And on each of them, you can see they have the level component, move speed component, and they are moving the translation. So you can see various of them, and they have various values. All right, so now that we have our zombies going up and down, let's try spawning some more. Here, in order to spawn more entities, all it takes is really modifying the size of this array. So I have 5. If I change it to 10, now all of a sudden we have 10 entities, and they all work exactly the same. They all have the same components and the same systems acting on those components. And here on the stats, you can see how fast the code is running. Right now taking 1 millisecond. So let's add a couple more. So instead of 10, let's add 1,000. And up here we have 1,000 entities. And as you can see, it's only taking 6 or 7 milliseconds. So let's try pushing it some more. Now let's put 10,000. And here we have 10,000 units. And as you can see, the frame rate finally starts to go down by a little bit. Now there's one improvement that we can make. As you can see, none of our sprites are being batched, so let's sort that. In order to do that, we just need to go into our material and enable GPU instancing. So for that, we could technically use the sprite's default. As you can see, it has the enable GPU instancing. However, for some reason, when we enable this, as you can see, these sprites disappear. So it seems there are some issues with this sprite shader when using GPU instancing. But another shader that works is to go into here, use the legacy shaders, and use the transparent diffuse. And just like that, they are now being seen. As you can see, they are all being batched. Again, remember, we have 10,000 independent units on the screen right now. If we had 10,000 game objects, our scene wouldn't be running at all. Now, one thing that is related to ECS is the burst compiler. And in order to enable burst using ECS, it's extremely simple. We just go up here into jobs, go into burst, and all we have to do is tick this. So let's see, this one is taking 50 milliseconds. Let's simply tick this and see how fast it goes. And if there you go, we went from 50 milliseconds to just 3. This is so good, it's pretty much magic. So with this, let's see how far we can push it. And here we have 100,000 entities, all showing, all moving around independently, and our frame rate is still at 40 frames per second. And on my task manager, here you can see my CPU being used at 77% and my GPU also being used at 60%. So in this video, we just covered the entity component system. Now, a big part of the massive performance you get is when you combine the entity component system with the burst compiler, which as you saw, and then with the job system as well. So if we were using the entire dot stack, we could probably push this up to maybe 200,000. So subscribe to the channel for more upcoming ECS tutorials using the complete dot stack with the job system, the burst compiler, just to see how much performance we can squeeze out of this new way of writing code. So to summarize the whole entity component system, the first thing you do is create an entity. You create entities according to a certain archetype, which is a group of components. Each entity then contains an instance of each component. The components are very simple, they just have fields and implement iComponent data. And then you have systems which act upon the data on those components. We define which entities we want to run on by defining the components that they must have, and then this code gets run on every single entity and modifies the instance of every component on that entity. So I hope this video has helped you understand and get started working with ECS. It might sound confusing at first, but once the core concept clicks, it's actually rather intuitive. As always, you can download the project files and utilities from unitycodemonkey.com. If you liked the video, subscribe to the channel for more Unity tutorials. Post any questions you have in the comments and I'll do my best to answer them. Alright, see you next time.